Let's solve one or two more problems. Let's say we have to evaluate f of t is equal to Laplace inverse of 5e to the power of minus 3s by s minus e to the power of minus s by s. So basically what we have to do is we have to convert this into a function of t. Yes, so let's see how to do that. Let's take it part by part. So Laplace inverse of 5 by s is equal to, we know 5 can be taken out, Laplace inverse of 1 by s, which is equal to 5, okay, because 1 by s is 1. Similarly, Laplace inverse of nothing is there, we can say it is 1 by s times e to the power of minus s. So 1 by s is equal to 1. Now let's take the other two parts. Laplace inverse of e to the power of minus 3s by s. This we can directly write it as g of t minus 3. Right? We know this. Similarly, Laplace inverse of e to the power of minus s by s is equal to, again, g of t minus 1. So we have got all these parts. So now we can write f of t is equal to 5 times g of t minus 3 minus 1 time g of t minus 1. Okay. Now remember, g of t minus a is equal to 0, 1. When t is less than a, it is 0. When t is greater than or equal to a, it is 1. So, okay, so this we have to remember. Now, when t is between 1 and 0, g of t minus 1 is equal to 0. Right? And g of t minus 3 equal to 0, which implies f of t equal to 0 when t is between 1 and 0. G of t minus 1, this is 0, this is 0. So that means f of t is 0. Okay. Now when t is between 3 and 1, then g of t minus 1 is equal to 1 and g of t minus 3 equal to 0. Now again, from where are we getting this 0 between 0 and 1 and 1 and 3? That we are taking it from this expressions t minus 1, t minus 3. Okay. So now if it is between 1 and 3, 1 and 3 means 1 minus 3, 1 minus 1. So when it is between 1 and 3, that means what? It is greater than 1. So that means this will be a positive number. So this will be equal to 1. Whereas here it would be a negative, less than 0. So which means it will be equal to 0. Here remember this is a. So when it is less than a, it is 0. Okay. So now with this f of t becomes, what is our 5 times g of t minus 3. 5 times 0 and then minus 1 times 1. Yes. Which is equal to 0. 0 minus 1, which is equal to minus 1. And when t is greater than or equal to 3, in that case what happens? In that case, g of t minus 3 is equal to 1 and g of t minus 1 is equal to 1. Okay? So which means f of t becomes 5 times 1 minus 1 times 1, which is 5 minus 1, which is 4. So we have got three conditions. And based on those conditions, we know what the function is. So let's combine them. So therefore, f of t is equal to, remember, it will be 0 or minus 1 or 4. 0, minus 1, 4. When will it be 0? When t is between 1 and 0. It will be minus 1 when it is between 1 and 3. And it will be 4 when t is greater than or equal to 3. So this is the Laplace inverse of that in terms of t as a function of t. Okay, now let's do one more problem. Let's say f of t is equal to Laplace inverse of s plus 1 e to the power of minus pi s by s square plus s plus 1. Again, what we have to do is write this as a function of t in terms of t. So let's take again part by part, s plus 1 by s square plus s plus 1. Now, what do we do here? Remember, the denominator, what we can do is we can perfect the square. So this becomes s plus half square plus root 3 by 2 square. Yes, actually, what happens is this becomes 3 by 4, right? And this 3 by 4 can be written as root 3 by 2 square. Okay, and the numerator, again, if we can write it in a specific way, so let's write it as s plus half plus half. That one can be split into two. Now remember, 1 by 2 can be written as 1 by root 3 times root 3 by 2, right? So just remember, let's break it up. So s plus half by s plus half square plus root 3 by 2 square plus, and we use this 1 by root 3 times root 3 by 2 by s plus half square plus root 3 by 2 square, right? Um, let's proceed. Laplace inverse of s plus 1 by s square plus s plus 1 can be written as Laplace inverse of s plus half by s plus half square plus root 3 by 2 square plus 1 by root 3 times root 3 by 2 by s plus 1 by 2 square plus root 3 by 2 square. Okay. Now, remember, Laplace of these two can be split into Laplace of this and Laplace of this. So now, Laplace of this would be what? Laplace of this would be e to the power of minus t by 2 times cos of root 3 by 2 t plus 1 by root 3, and the Laplace inverse of this would be e to the power of minus t by 2 sine root 3 by 2 t. Now, by second shifting property, Laplace inverse of s plus 1 by s square plus s plus 1 e to the power of pi s. Is it pi s or minus pi s? Minus pi s. So minus pi s is equal to e to the power of minus t minus pi. Remember, and let's take a different bracket because this would be, you know, same for both. Since this is common, let's take it out. Okay, cos root 3 by 2t, and now this t can be written as t minus pi plus 1 by root 3 sine of root 3 by 2 times t minus pi and u of t minus pi, and this is for all p greater than pi, and this would be Laplace inverse of s plus 1 e to the power of minus pi s by s square plus s plus 1 would be equal to 0 for all t less than pi. So this is the function. So what we can do is we can write f of t is equal to 0 when t is less than pi, and this entire expression, does say this is equal to, okay, let's write it, e to the power of minus t minus pi cos root 3 by 2 t minus pi plus 1 by root 3 sine root 3 by 2 t minus pi times u of t minus pi, and this is when t is greater than pi. So that is writing the Laplace inverse as a function of t. That's it for now. Bye.